So we're going to be talking about the magnetic fields of different magnets. So magnetic fields emerge from the magnet and they return to the magnet. They always emerge from what is the north pole of the magnet and they return to what is the south pole of the magnet. So the magnetic field will go out of the north pole and in to the south pole. It will go out of the north pole and in to the south pole. So when we have one magnet, you can see this picture of the iron filings aligning with the magnetic field, which is a way that we tell it's there. But that magnetic field is going to leave from the north pole and it's going to go into the south pole. It's going to push out of the north pole and it's going to wrap all the way around to the south pole. Every single one of those magnetic field lines that leaves is going to go back to the south pole after leaving the north. Now, the closer together the lines are, the stronger the magnetic field is going to be. So the lines are the closest together at the poles, and they're the weakest the farther you go out. The farther and farther you go out, the longer a trip that magnetic field line has to take to get back to the south pole. And you can see there's more and more space the further away we get from the magnet. So why do magnets attract and repel? Well, it's pretty basic. That field is leaving from the north pole and it's leaving from this north pole and they're bumping into each other and they're saying there's not enough space for us here, and since they are running into each other they push apart, and that magnet is accelerated that way and this magnet is accelerated that way. In like poles, now these magnets are still going to have a north and south pole. You can't have either one, just one. So it's going to leave the north pole, but since this is a south pole, it's just going to go into there instead of going all the way around to its own south pole. Now the north pole of this other magnet, its magnetic field lines don't have anywhere to go now, so they'll go all the way to this other south pole. And what that does is it merges the magnetic fields of those magnets, and this push from north to south pole brings them together. They're both attracted to the middle here, and they're brought together. Solenoids and electromagnets have the same principle where they leave from the pole of the magnet. You can see here this electromagnet is leaving from that pole and going to the other, leaving from its north pole and going from the other. Now, a reason an electromagnet is stronger when it has a core or a thicker core or a core of a different material is because it makes more of those magnetic field lines. And the more lines there are, the stronger that magnet is going to be. The Earth also has magnetic field lines, although they actually emerge from its south pole, because the Earth's south pole is like the north pole in a bar magnet. That's why the north pole of a magnet is going to point towards our north pole, is because it's actually the south pole of the Earth is a magnet, and that north pole is going to be attracted to the north, the south pole is going to be attracted to the south. So that's what makes the compass line up with these lines on the Earth.